So before we get started, let's go ahead and set up our project. We're going to go ahead and create a root node as a user interface, and we just have the mobile renderer selected. We don't need anything fancy for this. And there's one plugin I need to call out that I have installed here, and that is Script IDE, which you will be seeing and will make the editor look a little bit different, so don't be alarmed. If you'd like the same experience, just follow the link in the description. It'll send you over to Script IDE, and go ahead and download and install that into your own project. And then we've got some assets that we want to go ahead and import into our project. Links, again, are in the description. First one we've got is our Worlde icon, and then the next thing we need is going to be the Worlde font itself. And the goal of this video is to get familiar with the UI and the theming of the UI elements themselves. And we're going to start by looking at some project settings, getting some things set up here. So I pre-populated these a little bit. We've got Worlde as our title, obviously, and then on our icon selection, we just target our SVG. And then we're going to head over to Window in Display, and we're going to change the viewport width to 540, viewport height to 1080, and that's going to give us a viewport that resembles a mobile phone. Then if we come over to Theme under GUI, open the Custom Font dialog. Under your fonts, select Franklin Normal, and we'll need to create our theme resource. We don't have one yet, so don't save and restart, but we'll close this. And in the Resource Explorer, right-click, create a new resource. The resource type is theme. Create that, and we will just name this main. And then if we head back to our project settings, we haven't applied our font yet, so we don't see it. But if we go ahead, apply our theme and our font, make sure you save the scene. We'll just save this as main as well. And after you restart, if you double click your theme here, it should open at the bottom, and you can see that our font has adjusted. And so now everything is that Worlde font, and we don't have to worry about customizing that on each of the styles themselves. You can also see in your inspector, the theme has its own drop-down for default font. So if you wanted it to be theme level defined, that's easy enough to do. And we're going to go ahead and set our default font size to 16 pixels on our theme. Go ahead and save the whole project. We'll minimize the theme there. And then let's add our theme to our root node. And now this theme should apply to every control or every node underneath this control node at the top. And let's go ahead and apply our first style to the background here. And to do that, we are going to add a new type. As you can see, you can choose any of the base node types that are in here to style, or as you see, it says create a new custom type. We're going to go for the new custom type, and we'll just keep it simple, call this BG for background. And if we click over to our style box tab, we can see we don't have any options still. So what we need to do is click to the furthest right tab, and then we can provide a base type so this variation can be applied to those node types. So if we inherit from panel, we now have an option to define our own style box. Let's go ahead and click on the plus icon, and then we're going to define a new style box flat, and then we'll change our background color. The hex is 0E0F10. Submit that. Click back over to our control. We see type variation has nothing in our dropdown, and that's because our node is the incorrect type. So go ahead and change the control node that we started with to a panel. And then, as you can see in our type variation, we have our BG variation. Save and close that. All right, and we've got our canvas to work with. We'll just call this background. All right, and the first thing that we're going to do is just create the structure of the UI before we add any functionality of the game. So we'll add a child node to our background node. We're going to add a new center container, and this is going to be our layout node. Set the layout of the anchor preset to full rectangle. And this node does exactly as you'd expect. It will center everything that is a child of our container. For our rows of letters, we are going to add a grid container child to our center container. And this represents the row that contains all of the individual letters in our guess. So we only want one row. We're just going to need 5 columns in our grid. So for the individual letters, we'll need to add a panel node. And this will be a container node for our letter, and this will allow us to apply a style box to the panel for each of the individual states that the guesses can be in. And then to this, we need to add our label so that we can display the letter that we've guessed. And I'm going to go ahead and pop a letter in here so we've got that visual for styling. And let's quickly rename some of these nodes. So we'll refer to each box that contains letters as a tile. We're going to call this tile, but we're going to need several of them. So we're just going to index it and make this one tile 0. And then we will just call the label letter. And as we can see, the bounding rectangle is a little misshapen at the moment. So what we want to do is, with the letter still selected, open the layout dropdown, and then we're going to give this a custom minimum size of 64 by 64. Obviously, our text is now misaligned, so what we need to do is just come to the horizontal and vertical alignment on the label, and then set those to center. And we won't worry about any other styles on this for now. We'll do that with a variant in our theme. So let's click on our tile. And now let's make sure that our elements are going to align just right. And let's add some styles, make sure everything is copacetic. So just like before, we're going to add a new custom type, call this tile. And again, we are going to inherit from panel. And then again, a new style box flat. So the default tile is just going to be an empty box with a gray border. So what we need to do is uncheck draw center, and then we're going to up our border width, let's say 2 pixels. And the border color is not exact, but it's a light color, so that'll work for now. Now let's go ahead and apply our variation to the tile node, and it seems that our style isn't correct. But this is actually a layout issue. We need to apply our custom size not to the label, but to its container. So just quickly apply that 64 by 64 to our minimum size. Good deal. We've got a border, we've got our box. Time to add a new custom style to our label so we can adjust the font size properly. So we'll add a new class. We'll just call this tile letter. Straightforward enough. We will extend the label node for this one. Font is already correct, but font size, that is what we are going to need to adjust. So let's just bump this up to 32 pixels. And I honestly have no idea why it's not showing up there, but if you click the little pencil, type in tile letter, bada bing, bada boom, all is well. Okay. So we've got our one letter. Let's see what happens when we paste another one in the grid. Okay, that looks all right. We may need to adjust the spacing between these, but for now, I think we're doing okay. Let's just fill this out to see how it looks. Save this, close it, get us some more room here. Okay, so we verified our center container is working, our grid container is working, and then the sizing of our tile and label are aligned for now. To more easily get the rest of the colors for the theme, I've just taken a screenshot of the game. So let's go ahead and create the rest of our styles for the tile, and let's adjust the default to have the correct border color. So we'll go in here and select our tile, go back to our style box, and then open your border dropdown, click your eyedrop, and you'll see there's a couple different shades of gray here from the anti-aliasing. Just choose whatever the lighter hue of gray you can find is the lightest. That looks pretty good. Doesn't have to be perfect. That will work though. Now let's go ahead and add the other variants of our tile. And then just like our default, all of these are going to need to extend from the base type of panel. Let's go back through these, assign them all to panel, and let's go fill these out. So again, another flat style box, and we're just going background color for all of these, as we just want a solid color. We don't want the border. So that is correct. Now we'll do incorrect. Make sure that I can see it here before. All right. I dropped the incorrect background color and then the semi-correct. Okay. And now let's see if we can just flip through those, see how they look. Got the right color there, right color for incorrect, and the right color for semi-correct. All right, cool. We've got those different variants for the tile done. Go ahead and rename that grid container to tile row. And let's go ahead and delete the input placeholder A letter from all of these tiles. And instead of copying this tile row and then pasting it under center container or the 6 rows we need, what we're going to do is we're going to right click tile row and save branch as a scene. Now we can open our tile row as an individual scene, and any changes we make here will be reflected on any scenes for the tile row that we have instantiated in our main scene. So this is a good way of creating composable nodes, if you will, technically scenes, but scenes that you can load as a node in your main scene or whatever your current scene is. But by doing this, we've made this node opaque, meaning we can't access any of the children directly, so we can't access the tiles themselves. To fix this, we're going to need to create a script for tile row, and then we're going to need to access all of the children via the top level script. So we'll go ahead and add a script to tile row, and we'll also need to attach scripts to each of our tiles. So we'll just call this tile, and then attach that to all of the additional tiles as well. All right, we'll go ahead and name this class name tile. And of course, the tile will need a reference to our label. So go ahead and assign all of the proper labels to the correct tiles. All right. Heading back to our tile row script, we can now define a variable for our tiles, an array, and we'll just say control. That way it's just a generic, and we don't need to specify if it's a panel specifically or whatever this node is, because we don't really care what the type of it is. Click our tile row, and then we can go ahead and add each of our elements in here. So now if we head back to the main scene, you can see that we have access to all of our tiles at this level now. Go ahead and switch back to the scene view, and then we will just copy the rest of our tile rows, and we're going to rename just like we did for the tiles themselves, and then paste our 6 rows here. But it appears that our rows are all stacked on top of each other still. So we're going to select all of our tile rows, reparent them to a new node, and this is going to be a VBox container. And just like magic, we are good to go. Rename this tile rows. Let's just rename the background node to root, because we are going to need to attach another script to this. We'll call this root. And in this script, we are going to handle all of the input from our keyboard. And the way Godot suggests to handle things like keyboard input, where it's various letters, is to use the unhandled input, key input function. So instead of defining an input map with every single action for every single letter, we're just going to catch any unhandled key input. So anything that isn't an action is going to fall through to this function. So first thing we need to do is check and make sure our event is an input key event and that our event is pressed. And we'll need to write several filters here because all of the keyboard input that is unhandled will be coming through. The first filter we're going to apply is to check to see if our event is and echo. So for the repeat, we can just check event.echo. Now, if we control click input event key and we look into the docs here, we can see we have a Boolean named echo, got a key code, and then we actually have a pressed property. So technically, this just needs to be pressed. Is pressed will still work. So let's go ahead and ignore any of the repeating keys, except in the case of our backspace key, which we want to allow through so people can just hold it down to erase an entire guess. But it's not just single stroke combinations that are coming through, so we need to check the modifiers mask and make sure that is 0. And this will filter out any key combinations that come through as like a Control-Shift-Alt combination. Let's go ahead and update our comments here. So this is where we're going to handle our letter input. And we are going to further filter this down and say if our event key code is less or greater than or equal to key A and event key code is less than or equal to key Z. And this is where we'll handle the input logic for the guesses. Otherwise, we need to handle our one other key that is acceptable, which is going to be key enter so they can submit their guess. So each of the places it says pass is a good indicator. We're going to need another method to handle that functionality. So we'll just implement 3 placeholder functions here for handling guess input, submitting our guess, and removing letters from our current guess. And we'll go ahead and define a class name of tile row on our tile row script. Let's go ahead and define our reference to our tile rows. We'll create a variable to keep track of our current guess. And the data type for this is going to be an array because we're going to need to check each letter individually. And we're going to need to keep track of which guess we are currently on. And now that we're tracking the guess, we can go ahead and implement some basic functionality to test our methods here. So the guess input and erase input are going to be working with just one letter at a time. And then our submit guess will have access to our current guess. We won't need to pass anything to that. And then our input is going to be event as text for both of these. And then for some crude debugging, we'll just replace all of our pass statements with some print statements and see what we get for output. So we expect our letters to be passed through, our erase or backspace to work, and then enter should print the current guess. Let's open up our output, and we'll just do ASDF. Perfect. Let's hit enter. Ooh, looks like we're not updating our current guess. That's fine. And then it looks like backspace isn't registering. So obviously we're not adding any of our letters to our current guess. So let's go ahead and add an extra line where we append that here. Fire this back up. There we go. So now we've got our letters into our current guess properly. But it looks like backspace is still on the fritz. And the reason for that is that we are not triggering an echo whenever we're just hitting it once. We want to handle both, so we're just going to remove that entirely so that anytime our backspace key comes through, it will be registered off of a echo or not. Okay, we're registering backspace, but we haven't actually added the functionality to remove from our guess, so let's go ahead and do that. So we'll need to modify our current guess. And we're just going to use the pop back function, which will just pop the last item out of the array. And then we're going to change this to log our current guess so we can see it in action. And there we go. Awesome. And we'll add some additional checks to make sure that we are not exceeding the number of letters allowed in a guess. So if the current size is less than or equal to 4, then we're going to allow those guesses through. And then for erase, if the current size is greater than 0, then we will allow. And then for the guess, we need to make sure our current guess size is equal to 5. So it has all of the letters of the guess filled out. Open up our output. Give it one more chance here. Good deal. I'm only able to enter 5 keys. Let's hit backspace. That's all still working. I'm going to hit enter now to submit. Unable to submit. Still unable to submit. Hit my last letter in there, and submit is allowed. Perfect. So we've got our framework for handling input. Now we need to handle the orchestration of keyboard input to the correct row. So earlier we defined our guess index, and that is going to be the current guess that we're on, at least correlated to the tile row. So the first row, guess index, tile row 0. So let's create some convenience variables here. We're going to do a current tile variable and a previous tile variable. And we'll take this one step further, and we are going to make these getters only. So the current tile is going to be our tile rows with our guess index. And then the tile we're after is going to be the row tiles. And then for the index, we can use the size of our current guess, but we need to make sure we don't exceed our maximum array size. So we're going to say the minimum of our current guess size and then 4 to cap it at that last index. And we'll repeat a similar method for previous tile, except this is going to be the max of current guess size minus 1 and 0. That way we have a floor of 0 and a ceiling of 4 for our indexes. So now we've got some reliable references to our tiles we're interested in. We can go back to our previously defined methods and fill out the actual logic for this. We've already got our safeguard checking the size of our current guess array, so we just need to update the current tile and update the label text to be our key. And then following a similar pattern, we are going to just erase the previous tile label text on the erase input. So let's run this and see what is going to happen. Okay, we've got something coming in, but it looks like our index is one off here. So let's go and track that down and fix it. And we've already run into a gotcha of our own making. So by updating current guess before applying the label text, we have updated the tile position before we've updated the actual text. So be careful when employing fancy syntactic sugar, as I've done here, as it can bite you in various unexpected ways. But let's see if that actually solved our issue. All right, let's enter our letters. Won't let me enter any more. Perfect. Backspace works. Our entry works. Let's see if we can submit and bump it to the next row. So for submission, all we need to do for now is bump that index by 1. Save that, and let's see what happens. Hitting enter, but we should still be on the first row. Good deal. I'm going to hit enter again, and now we should be on the second row. No such luck. Let's figure out what went wrong. Well, everything is operating off of our current guess variable, but we never reset our current guess after we submit the first row. See if this changes anything. I think that may have been the problem. We're making progress. But how do we define our target word and then compare against that? All right, so we're going to create a custom resource. We're going to need a new script. We're going to call this daily word and inherit from resource. Go ahead and define the class name as daily word, and then define a variable for our word. And you can find a full list of possible Wordle words with a quick Google search. So just go ahead and find that resource, copy those into a new text file. And we're going to name that text file available words. And as you can see, we've got about 15,000 entries, so this should keep you busy for a little while. Close that back out. Get back to our daily word script here. And we are going to want to automatically populate our daily word from this text file when our daily word resource is created. So first thing we need to do is open the file for available words. And to do that, we'll use the global class file access. Call the open method here. And instead of hard coding a string, I'm just going to drop in available words. And if you're on one of the newer versions of Godot, this will be a resource ID instead of a resource path. And I definitely recommend that route. And then the other parameter we'll need to give it is the level of access we're requesting. Now that we have access, we need to go ahead and read through each line inside of this file. So we want to say, while we are not at the end of the file, continue, and we'll need to define a new variable for our available words. We'll call getLine to read it as a string. And then we will go ahead and transform these all to uppercase just to make it easy on us when we're doing the comparisons. And it turns out spelling matters. Inversely, we will need to check which words have already been used. So we'll just create another variable and we'll just call this unavailable. And we don't have this resource yet, but just copy paste this, call it unavailable words. And of course, we'll need to track these as well. So when we create our daily word, we will load all of the available and unavailable words. And instead of updating the available words list and removing words that are being used, we're just going to append to the unavailable words and then filter those used words out of our current list. So while we populate our unavailable words, we're just going to strip out the used words from our current available words list. So we'll define the variable word index, and then we will search through our available words array, attempting to find our used word. And to reuse this, quickly define an unavailable word local variable. And if we find a match, then we will go ahead and remove that word from our list. Now at this point, after we've read both files and filtered our available words, we can assign our daily word. And we'll want to grab a random word from our available words list. So we're going to use a function called randi_range, and that's going to get us a random integer. And the range will be 0 to the size of our array minus 1. And let's go ahead and create our unavailable words text file. Now let's go ahead and create a new resource of daily word, which call this test. And it doesn't appear that our daily word is being populated. And that's because our resource is not attached to any nodes right now, so the init is never going to be ran. But what we can do is make this script a tool, and that will allow it to run code in the editor itself instead of only at runtime. Let's go ahead and remake this resource. Do the same thing. Daily word. And now you can see we have populated our daily word from our list of available words. And we are going to be using the resource in this manner. So you can go ahead and remove that test resource. we've at least seen that we can load the available words, and we'll test the rest as we go along. So we've defined our daily word, but we need a way to compare against our daily words. So let's just go ahead and implement a compare function on our daily word script. And because our data types can be either a string or an array of characters, we're going to make this argument for compare polymorphic. So we'll just define word without a type, and then we'll do some type checking to determine how we want to handle this. So if we have an array, handle it one way. Otherwise, make sure it's a string, and we'll handle it a different way. And only two equals. This is not JavaScript. And we don't want to implement two different ways of comparing. We just want to use these to transform the data into something we're expecting. So for our comparison, it'll be easiest to work with arrays. We'll just define a local array variable, and then we'll populate this based on our word input parameter. So if we've got a type of array, pretty easy. We just need to set our comparison target to the word. Otherwise, we will need to split our string into a character array. It's incredibly simple to do with a string. We're just going to call split on word. And this as string is not doing anything to affect word. It is just adding a hint to the IDE so I get autocomplete for string functions and other string methods. All right, and the next part is pretty straightforward. We just need to iterate through each letter in the guess and determine the correctness of our current guess. And we'll use a little syntactic sugar again here to create a helpful little getter for our daily word letters. And again, pretty straightforward implementation. We're just going to call split on our daily word, and that's going to return all of our daily letters. So if our daily letter in this position is equal to our comp position, then we will return 0 for correct, and we'll replace these with an enum in just a moment. Otherwise, if we have an instance of the letter somewhere in the word, we will return semi-correct, and otherwise, we will return incorrect. And to easily keep track of our different states, let's go ahead and create a new a new script. We'll just call this game state. Go ahead and define an enum for our tile status. Correct, semi-correct, and incorrect. Go ahead and save this. Enter our project settings. Load up game state as a global. And make sure not to name the class game state here, otherwise it will clash and you won't be able to add it as a global. So we've got our game state. Go back and replace these variables. All right, we're on the right path, but we shouldn't be returning here. We need to return one state for each letter in the word. So we'll need to create a new variable to keep track of our results. And again, this just needs to be an array. And instead of returning down here, we're just going to assign our results for this slot and return the entire results array. And we're going to need to create a new word for each game being played or each day. So let's define a global resource preloader. And then when our game state initializes, let's add our resource of daily word. And now back in our root script, we can add an initialization function. And let's create our target word. So just assign target word equal to game state preloader, get resource daily word, and create a new instance of our target word. And just so we can see it show up, I'm going to export this variable and let's give it another look. So we need to come over to our remote, click on our root, and it looks like we have our target word. But it looks like we've got a type mismatch on our daily letters getter. So be a packed string array. So our daily word's being generated. Let's see if our compare function is going to work. So when we're submitting our guess, we need to get our target word, call compare with our current guess. And since we're not doing anything with these values yet, I'm just going to print the result to the console. But it seems we've hit another snag. And the problem is we're trying to access an index that doesn't exist in our array. So what we can do is convert this to a dictionary. And the accessor methods will all remain the same, but this way we have an entry for each of our guess spots. Let's give that another try. Anything works for the entry. I'm going to hit enter. And now in our output, we have our results. So it looks like the second to last letter was correct and the one before that was semi-correct. So the next thing to do would be to update the styles and colors of all of our individual letters in the guess. And we've already defined our styles for that. So that should be pretty straightforward. Go ahead and open your tile script. We'll delete all of this default code here. We'll declare a new theme variance variable, and this is going to be an array. And inside of this array, we are just going to define our styles as we have defined them in the theme. And the order here should match the order in your enum, so correct, semi-correct, incorrect. That way we can just index the theme variance with the value of our enum. And we'll just define a function called submit. And this is going to take the tile status, which is going to be our game state tile status enum. And this will simply return the correct theme variant. Go ahead and save that. Now we can come back to our print statement, get rid of that, and we will store our results in this variable here. I'm going to update guess index to current row index to be a little more clear. And we need to get a reference to our current tiles in the current row. So we will access the tile rows at our row index and get the tiles from that. Next, we just need to simply iterate over our results and our tiles, and then simply call our current tiles at this index with the submit function and our results at the same index. And I didn't get any autocomplete here, so I think something's going on. If we go to our tile row, we can see we haven't updated our tiles from a generic control type to a tile type. And if we add this, that will actually give us our type inference. And then we just need to simply pass our results to our submit function. And we don't actually want to return this here. We want to just go ahead and set our theme type variation directly on our tile. Play this. Horrible guess, but that looks like it's working. Let's try something else just for peace of mind. Okay, cool. So it's not bugged. We are getting some feedback that's correct here. Awesome. So that is working. Now let's give it some animation. So we're just going to define an animate function. And first thing we want to do is create a tween object. So called getTree create tween. Set our transition to a spring. And then we are going to tween the property on this object of scale. And we are just going to scale this up. We'll start with 1.5 as our value. And we'll just do this over a half a second. Now that'll scale it up, but we need to scale it back down as well. So set it back to scale 1. And I'm going to go ahead and remove the animation parameter here. We'll add it when we need it, but for now, this is the only animation. So we'll just call animate on our submit. All right, that looked pretty good, except our anchor is still on the top left. So everything is scaling from the top left to the bottom right. Fix that, we need to adjust the pivot offset. So go ahead and set our pivot offset equal to our size X divided by 2 and size Y divided by 2. And that should center it up for us. All right, cool. That was a little extreme, but we're at least aligned properly now. So now we can tweak these values. Let's go ahead, adjust this to be a little quicker. And then let's just get it to shrink back down a little differently. All right, that wasn't horrible. Let's try another one here. Yeah, we can live with that. Cool. And we have the same animation on our keystrokes. So where we are handling the input, we just access our current tile here. And then we just need to animate that on our entry. Awesome. All right, well, that's going to wrap up this first part. We've got a playable game for all intents and purposes. Next, we'll implement the keyboard at the bottom to show what letters are available and what's been used. And although it may not be perfect, it is playable, so play some Wordle.